Alright, ciao Am. So, today we're going to learn the second part of complex numbers, the part that we kind of left out yesterday. So far we learned how to add, subtract, multiply, and simplify. So today we're going to actually do a little bit more simplifying with the division kind of aspect into it. And before we talked about this, the same thing with imaginary numbers kind of apply with radicals. Let's take a look. Let's say I have a problem like this. Example. I have, let's say, 3 divided by the square root of 2. When you have a fraction, there's 3 things you can't have at the bottom of a fraction. 1 is radicals, 2 is zeros, and 3 is imaginary numbers. So first off, you have a radical at the bottom. Do you guys remember how to get radicals? So, if you don't remember, basically radical means we want to take 2 out, correct? We already have 1, we create a second one, multiply top and bottom because that's equal to 1. Multiply across, that becomes 3 square root of 2. The bottom becomes square root of 2 times square root of 2 is square root of 4, which is 3 square root of 2 divided by 2. By doing that, we got rid of the radical. Hopefully you remember that from Algebra 1. I don't want to get too much into it. But that idea still applies with complex numbers and imaginary numbers. Let me give an example. This is example 2. Same idea. We have 3 divided by, now instead of radical 2, we're going to say 2i. 3 things we can't have at the bottom: zeros, radicals, and imaginary numbers. We have imaginary at the bottom. So we have a problem here. How do you get rid of that imaginary at the bottom? You have to remember what imaginary is. Remember, I is imaginary, good, and I squared is -1, good. So the way to get rid of I is to make it squared. Just the same reason, how do you get rid of radical? Make it squared. Make 2 of them. We have to make 2 of them. To get rid of I at the bottom, take a look. I'm going to multiply by just I. And watch what that does. Take a look. The top becomes 3i. And why top and bottom? Because I divided by I is just 1. The bottom becomes 2i squared. And you could ask, well, Mr. Tang, that didn't get rid of i's at all. You just made it I squared. But remember, what's I squared again? I squared is, good, -1. So take a look. This is 3. This is 3i divided by 2. I squared, but I squared, isn't I squared the same as -1? So can I replace that? Take out the I squared and replace it with -1. So what does that leave? That leaves my final answer of 3i divided by 2 times -1 is -2. You may write it like this, or you may write it like this. Those are the same things. Remember, the negatives being top, bottom, outside, same thing. So how do you guys feel? Do you understand the idea? So if you want to get rid of I, just multiply by another I to get I squared. If you want to get rid of a radical, multiply by the same radical, and it also goes away. So, using those ideas, that's how you get rid of or simplify the imaginary at the bottom and radical at the bottom. Let's get something a little more complicated. What happens if you have something like this? Example 3. What happens if you have something like this? We have a 2 divided by 3 minus 2i. Alright, just watch. Don't write this down yet. Okay, using that same idea, it goes, I want an I to go away because there can't be any imaginaries at the bottom. So I'm going to multiply by I to create an I squared. Take a look at what happens here. I multiply top and bottom by I, top and bottom by I. Top becomes 2i. The bottom, how do I multiply that? Remember, you have to distribute. That becomes 3i minus 2i squared. Very good. But hold on here. This becomes 2i at the bottom. This I right here, can I change that? No. So that's still a 3i, but minus 2 I squared is -1. Replace that with -1. That gives me a 2i divided by 3i plus 2, or 2i divided by 2 plus 3i. That's kind of weird. The I really didn't go away. It kind of just moved. So what do I do now? A lot of you guys might think, let's multiply by another I. if you do that, just give it a try, you're going to end up back to the original. So you're going to be this kind of circular rotation going, how did I get rid of this? And this actually takes a little bit more knowledge. So I'm going to show you something. Take a look. Before we go back to this problem, I want to show you something. I want you to multiply this. So pause the video, write this down, and multiply this. Example, what are we on? 4. Can you multiply this out? 2 plus 3i times 2 minus 3i. Can you multiply that out, please, by distribution? Pause it, multiply it out. Example 5. Give me a number, any number you want. Good, 5, I heard that. Plus, let's do minus this time. Minus 4i times 5 plus 4i. Good. Can you multiply that out for me? Good. So I'll give you a couple of seconds to multiply that out. Hopefully you pause that video. And you should end up something like this. You should end up with 4 minus 6i plus 6i minus 9i squared. And you notice something special. When you combine like terms, this middle part here tends to cancel out. As negative 6i and a positive 6i goes away, leaving 4 minus 9i squared. Wait, what's I squared again? Good, it's negative 1. That's 4 minus 9 times negative 1, which is just 4 plus 9, which is 13. That's interesting, right? Do the same thing with the next one. You should get 25 plus 20i minus 20i minus 16i squared. What'd you notice again? Look carefully. When you combine like terms, the middle goes away again. Isn't that kind of interesting? This goes away again, leaving 25 minus 16i squared. Hold on, what's I squared again? That's right, negative 1. That's 25 minus 16 times negative 1, which is 25 plus 16, which is 20, 30, 41. Interesting. What do you notice special about these two numbers? When you multiply them out, your final answer actually has no I in it. And that's actually something very special. This is actually something that we're going to use a lot. It's called conjugate. Conjugate. And what makes these two things conjugate? Let's look at the first one and look at the second one. These two numbers are conjugates of each other. What's special about them? Look carefully. Are the numbers different? No, the numbers are the same. The only difference are the signs in the middle. So take a look. Look at this one right here. And look at this one right here. Those are conjugates of each other. The numbers are the same, but the sign in the middle is different. 5 and 5, 4 and 4. Only thing is a minus and a plus, a minus and a plus. So conjugates are basically the same numbers, but different signs. So the same, but different. That's special. Why? Because when you multiply conjugates together, the imaginary numbers go away. Even with radicals, when you multiply radical conjugates together, the radicals will go away. Very, very cool. So let's go back to this problem, which is a huge mess. And when I multiply by I, it kind of goes back and forth, back and forth. So I'm going to do something different now. I'm going to actually multiply by the conjugate. And how does the conjugate work? Conjugate actually different between this problem, number 2, and example number 3, is that example number 2 has a single number with I, a single term there, 2i. So when you multiply it, it only sticks to that term. The problem with number 3 is there's 2 terms. So when you're multiplying I kind of goes to the second term and really doesn't fix itself. So what I do here, I multiply by the conjugate, which is 3 plus 2i. Top and bottom because we want to only multiply by 1. Doesn't change the problem. Distribute the top. That becomes 6 plus 4i. Multiply the bottom. Take a look. That's 3 times 3, which is 9. That becomes positive 6i, negative 6i, and negative 4i squared. Take a look. Something special happened like we predicted. This part right here goes away. Cancels out because 6i and negative 6i make 0. The top stays the same still. 6 plus 4i. The bottom becomes 9 minus 4i squared. But hold on. Do you remember what I squared is? Good. You guys have good memory. It is negative 1. So this becomes 6 plus 4i. The bottom becomes 9. Negative negatives a plus 4. Your final answer, 6 plus 4i divided by 13. Take a look. No imaginary at the bottom. You simplify the problem. If there is imaginary, if you can't simplify anymore, like there's a number that divides into everything, you must simplify some more. Alright, that's what we have to learn about imaginary numbers. So we kind of took some more time to show you about that. Before we move on today, I want to actually start you off for the next lesson too. So take a look at these problems right here. And I want you to write this down. I want you to factor these 6 problems. Pause. Pause. Okay, good, you pause, right? Factor them. After you're done factoring, unpause. And you should get answers like this. There's a relationship between these answers, and these are special too. These are actually perfect squares. Yes, and we're going to learn tomorrow something called completing the square. So, for your questions at the bottom, I'm going to ask you one specific question. Make a relationship, because this is like ax squared plus bx plus c. Find some kind of relationship between the a, b's, and c's and this number right here. How is a, b, and c related to those numbers? And don't make like, oh, in problem 1 is related this way, in problem 2. Make a relationship where all 6 problems are related the same way. Think about it, really, and I want you to write down at least one relationship between these things. Doesn't have to be all a, b, and c. It could be just a, it could be just b, it could be just c, and related to this number right here, this number right here, this number right here, this number right here. How are the relationship? Think about it. Alright, that's it. Have a great day. I'll see you tomorrow.